Hola, mi nombre es Corey Johnson. Soy un jefe de producto de Unity Technologies. Felicidades, esta es la última vez que ustedes tienen escucharme hablar español. So yeah, this is my last talk. So. Oops. All right. Perfect. All right. Go. So today I'm going to do kind of a Unity graphics talk. I'm going to focus a lot on image effects and progressive light mapping, but I kind of crammed some stuff in. And that's just a video of Adam, but I wanted to show you it running in real time because it's a lot cooler, and we all watched it at the keynote. But yeah, so just so you know, this is a GTX 980 desktop card in a laptop. Luckily, I don't have to haul it around because it's a beast. But so there you saw that it's possible to run in real time in the editor, rendering twice, once in the scene view, once in the game view. You can be editing it and stuff like that. You might want slightly more RAM, but it's possible. And it's not only does it look good, but it looks good on hardware that gamers might actually have in their machine. So we're extremely proud of that. So what am I talking about today? Some random things I tacked on that I put on at the beginning because they're quick. I'm going to talk about our cinematic image effects package. I'm going to talk about progressive light mapper, which is a new feature that's coming up in future versions. And then I'm going to talk about what we're working on currently, and then hopefully we'll have time for questions at the end. So the first thing I want to talk about is a feature coming in 5.4, and that's multi-threaded rendering. And if we want the lights back on, we can turn the lights back on. So what is multi-threaded rendering? So in 5.3 and in single-threaded, non-multi-threaded rendering, basically this is what you have going on. You have a bunch of cores on your CPU, and they're all standing around, they're hype men. They're just sitting around doing nothing while the main thread in the middle is doing all the work, getting overloaded, and that. So we've been working a lot on multi-threading the engine. So what are the kind of things that happen on the main thread? We run our render loops, sorting the renders, figuring out what to draw, setting up the lights and materials for rendering, and then passing that all to the GPU. All happens on the CPU. So with multi-threaded rendering, as you can see, we have a lot more of these worker threads now working. You probably can't see, but there's like this depth pass and shadow jobs and all sorts of things. But what that means is that all that work isn't being done on the main thread. So there's more time on the main thread for you guys to run your code and get more stuff done and update more simulations or whatever. And so far, we've gotten some really good results from profiling that. So here we see in 5.3 on the main thread, this is real-world captured data from a project I can't announce, but it's a AAA going on console product. On the main thread, you can see in 5.3, we're taking 10.6 milliseconds just for rendering. That means that if you're trying to hit 16 millisecond frames, you didn't have a lot of time left. In 5.4, just by doing optimizations, we got it down to 7.4. And on the render thread, we optimized it and got you 3 milliseconds back there. This project happens to be in VR, so they're rendering everything twice. So it has, I'll hint at another feature if you're doing VR development that we have in 5.4 called single pass or double wide rendering or single pass stereo rendering. And basically what that does is all the things that you would normally do per camera, like culling, shadow pass, figuring out what to draw. Since we know that in like a stereo setup, the cameras are almost pointed the same place, and they're only separated by like less than 100 centimeters. We can take that assumption and make a lot of optimizations on it. So we do culling once, we do render passing, shadow rendering once, and then we just kind of like skew it a little bit for the other eye. We do things like figuring out what to draw, sorting the renders. We do all that once. And then just at the very end of the whole pipeline, we say, oh, by the way, render this cube once on the right eye, once on the left eye. So it saves a lot of time. We also turned on multi-threaded rendering. So here you can see in 5.4 with just double wide, we got down to 4 milliseconds. And then when we turned on multi-threaded rendering, we got down to 1.9 milliseconds on the main thread. Or sorry, on the CPU, but basically the main thread is what we're profiling here. And on the render thread, like that's what's happening. Sorry, that's the thread that is not on the GPU. I just want to make that clear. The render thread means there's a dedicated thread for passing things off and interfacing with the GPU. And that's the one where we only went down to 7.2. But as you can see, we got a 5x performance on the main thread, and on the render thread, we got like a 2x improvement. So it's still a big win, and it still gives you a lot of space. So in 5.4 in the player settings, there is I think it's just called multi-threaded render, but who knows what they'll change it to by the time that gets released. But yeah, make sure if you're, especially on like PCs and things like that, or if you have multi-threads on, it's not quite as good on mobile yet, because like mobiles don't have as many cores, but they'll get there. Just quick, how did they do it? So we get asked a lot in the Atom demo how we did that scene where he's ripping that cloth off of him. And I just wanted to point out that that was a Alembic animation. And so our team in Japan worked with a company called Marza Animation Planet on the gift. You can look up, if you haven't seen it, it's a really good non-real-time but built a CG movie built in Unity. So they used it there, and then the demo team in Stockholm got a hold of it and did the scenes like this where you can tear it off. And it's open source on the GitHub. There's a link in the notes of my presentation, which will be linked to in the video online. All right, so cinematic image effects, and here's where I run out of room to use my mouse and things get fun. But let's play. So let's escape out of that and go here, and then go. Nope. There we go. That's Atom. Here we go. So here I just have our standard corridor scene, which you may have seen. It's part of our Unity Labs standard asset package that we have in the asset store. But here I just have a bunch of image effects turned on, so it looks good. And things bounce around. Let me maximize that on play. Okay, so we have, as we saw, we have a pretty good looking scene here. So I'm just going to select our main camera. And we can see that we have all of our cinematic image effects. So I'm just going to take you through them real quick, talk about what they do and what they're useful for. And so the first thing I'm going to do is just take them all off so I can reapply them one by one. So you can see that even by just taking it all off, like you can see how much it added. The scene looks a lot more flat and just boring. So let's see what the different image effects do and how they help. So the first one that we're going to do is screen space reflection. And you can see as I turn it on and off, like we get much better reflections. If you look here at these giant white lights, especially on the floor there, we just get better, more realistic reflections. You can see down in the puddle there, we just get like more accurate lighting underneath the bucket in the corner there. So what is happening here? So screen space reflection is basically, it's a screen, it's in screen space. So that means the only things getting reflected are the things that are currently being rendered on the screen. And this can be good or bad. So this is why you kind of need to know when to use it. So for instance, if one of these balls was bouncing just off the screen to the right, and say I had a section where I could see it being rendered, I could see the reflection, but then the actual object itself went off the screen, suddenly the reflection would just disappear. because we only reflect what's on the screen. That's what makes it so fast, but it also makes it a little bit tricky if your camera's moving a lot and you like are doing a pan shot and you have screen space reflection on. Suddenly along the edges, things reflections will pop out because the object's being culled and the screen space, the reflection just disappears. Even though the object, in order to fix that, you'd have to make sure things aren't culled all the way out. So I'm going to show you some of our debug modes here so we can kind of see what's going on. So here we can use color to see like how specular each object is. So the more intense, in this case, this red ball is the most reflective thing in our scene. Here. So basically we have a ton of different things, so you guys can go through and look at the roughness of each object. You can see that the spherical balls have 0 roughness. You can see this is the result that's being applied on top of the scene and being blended with the final scene. So this is just what the image effect is adding to the scene. So you can see a lot of the details that it's adding. The next one we'll talk about is anti-aliasing. So let me find a good place. So if you notice, it might be a little hard to see because the projector is a little bit blurry, but if you look online, maybe it'll show up better. But if you look at, let's see if I can use our new zoom in the game mode feature here. And you can see here, there's a lot of aliasing going on, especially on right there. So if I turn on anti-aliasing, you can see that, especially if you look right down here in the bottom right or right here along the, I don't know what you call these support things in the hallway. You can see it just gets smoothed out a little bit. It's a little less rough on the eyes, especially right here. So again, I have the quality set to ultra. All of our image effects are being designed to scale up and down to mobile. Some of them flat out won't work on mobile, but it's up to you. We can't really tell you, hey, unless this technique doesn't work, we can't really tell you, hey, don't use this on mobile, because it's really up to you and what the effect you want is and how much of performance you're willing to pay for that. In this case, I would say that anti-aliasing, especially if you're doing VR on mobile, or just VR in general, is one of the few image effects that you want to make sure you use, especially if you're doing VR, because your head normally bobs around, and if you're in a VR headset, these little anti-alias we call jaggies will literally crawl all over because your head's always going to be moving slightly and your eyes are moving slightly. So aliasing really stands out in VR. So mobile VR, PC VR, definitely turn on anti-aliasing for that. It is worth it. We can change, they have some pretty standard things. You can change based on luminosity, color, or depth, how you're finding the edges. So again, that's really good for, like, color might be bad if you have like really thin things in the background. Color might not be a good way to detect those edges, because if they're super thin, they might just kind of blend in, and like the jaggies that'll be rendered will actually cause the colors to kind of wash out. So you might want to use depth or some other way to detect the edges. Ambient occlusion. So let me zoom out here. So what ambient occlusion is imagine you have your back of your hand and light bounces into the cracks of your fingers, and because it's a concave shape, light's going to bounce in there and it's going to not escape as well. So what ambient occlusion does is basically fakes that. Instead of like having our real-time lights figure out where the light's hitting and see whether it bounces out, we're going to calculate on what's on screen, what will actually cause that effect. So we basically check the normals and look for creases, and then in those darkened spots, we just artificially darken it. You can go in there and play with it. So I can show you like the intensity, so you can see like we get some really black lines there. That's a little bit too much, maybe not well much. And again, we have debug view, so you can see exactly all of this darkness is what we're actually adding to the scene. And it gives it a little bit more depth for very cheap. So instead of calculating each pixel and trying to figure out like, hey, am I next to something that's close, that's going to prevent light from escaping from reflecting off me. We just figure that out per what's on screen. Bloom. Hopefully you all know this. If you've seen like a J.J. Abrams movie, you're familiar with Bloom. So I can crank it up, and you can kind of get it. Like I think we're at Star Trek levels now. I guess that's lens flare. That's not really fair. It's lens flare. But so basically, all it does is find anywhere on the screen where we have a high white value, and then amplifies that even more and causes it to wash out. So it's a multipass, so it washes out over the entire thing. So the light kind of bleeds out. This technique reflects kind of how the human eye works, where if you stare at a bright light, it kind of like washes out because it's so bright, it kind of washes out the area where the light's just hitting. Other than intensity, there's not a lot of features for that one. Next one's one of my personal favorites, depth of field. So for this one, it's really good for like setting the focus. If you have a cut scene where two characters are talking and you want the focus to be on the facial animation or something like that, you really want to blur it. And so I'm going to turn on the visualize blurriness here. And what this is doing is that everything in yellow is being blurred because it's too close. It's too close than what I'm focused on. And everything in blue in the back is too far away for me to focus on. So everything in black there is kind of what will be sharp and in focus. And then you can come in here and change these planes as you see fit. So this is how wide the band of focus is. So I'm going to set it pretty narrow just for effects. You can tweak the range even more. And then if I disable this, hopefully, you can especially tell like down here in the bottom right or the bucket, if I turn this on and off, and then far back, you can see that like, oh, hey, like, you know, if things are moving across that plane of focus, like it'll draw my attention to it. It's also animated. I don't know if you noticed there's a scene in Adam where the robot picks up his hand and they actually animate the near plane focus to kind of like draw people's eyes to his hand. Tone mapping. So tone mapping and color grading, and they're kind of two words for the same thing. Basically what they are is you're remapping one color space to another color space. So this is good for eye adaptation. So this is for an effect where like you want people to kind of walk in and initially blown out and you want to like scale it down. Tone mapping is really good for, so color grading is really good for if you want to produce an emotional feel like a cinema would. So like if I want to make this feel like a science fiction thing, I might come in here and make everything green, and now we're in the Matrix. If I want people to be sad, I'll come in here and be like, oh no, everything's blue. You know, things like that. And there's a lot of studies in the cinematic universe about how like these colors and kind of like, if you just Google it, you'll find lots of articles talking about how like, you know, different movie genres trick you and like trigger certain emotional by like filtering the entire scene with a certain color. Like if I wanted to be like a modern day shooter, I'd find some brown, I guess. Ooh, yellow. Oh God, I'll just turn this one off for now because I totally foobarred that one. But yeah, so the key here is, again, the whole point here is that you're remapping your color spaces, and you can actually provide a lookup table to do it if you wanted to, and it's just a texture that has a color ramp, and basically wherever it finds, it'll look up where it would normally find a color and like a kind of a color gradient, and then you can say, no, when you're here, it's this color. So you can change how the colors ramp into each other and reduce other colors from coming in, if that makes sense. Last one, lens aberrations. The best one here is vignette. It's very easy, so I'm just going to crank up the intensity here. And this is like you think old-timey movies where they have like a, you know, there's circular aperture and they didn't have a square capture screen, so like you just got these circular images. So again, it's another one that's good for providing a sense of like focus and impendingness of like, oh, like I don't know why, but everything around me is dark. You can change the color, and you can change how saturated it is. So if I do this, It's how much of the color underneath. I don't think I picked a good color to show it, but basically you can choose how much of the original color from the image actually bleeds through the vignette effect. The other effects in here are chromatic aberration. Unless you're doing a game that's based in the 80s, you should probably never use chromatic aberration. And then you can just do weird distortions and things like that. Whee! Okay. I'm going to turn those off because, I foobarred those, so I'm not an artist. But as you can see, is like you can drastically change the way your scene looks and feels by using these image effects. And you can, it's a good way to take, good art and make it great, and crappy art and make it good. Trust me, I've used it. So, and it's a good way to invoke feelings in your users. It's a good way to draw their attention to certain things. Yeah, and in the case, I'll repeat this again because it's important. Anti-aliasing for VR, very important. Cool. So I just want to point out that all of these image effects are available today. You can download them from our GitHub. You can install them and use them. These are the same effects that we use in the Atom demo -1, which is volumetric fog, which will be coming in soon. And these are actually probably more stable and more optimized for this. Most of them have fallbacks for, and you'll be warned when you can't, but most of these have fallbacks for mobile if you want to use them. Again, that's not necessarily means they're recommended, but one of the things you can do is if you have a mobile game and then you have a cutscene in the mobile game, you can say, oh, well, since I'm not simulating all my characters and all this and rendering all this stuff and I have a really tight action scene, let me turn on a couple of these and use, choose when you spend your performance on these effects versus gameplay. Just know that it'll provide a jarring difference between your gameplay and those cinematic effects. So I'm going to close this now. Come back over here and Shift F5. Maybe. There we go. I have some placeholders just in case my computer crashes. Just jump through these real quick. All right. The next thing I'm going to talk about is our progressive light mapper. And you'll start being able to play around with this hopefully later this year. So what is it? So first we need to talk about what's a light map. So as you can see here on the left, I have a demo scene that we got from the asset store. It's called Multi-Story Dungeon. It's a great set of assets. We just downloaded it and used it as is. The only thing we did is we went in and set all the lights to baked because they had a bunch of real-time lights. We just set them all to baked to show off a light mapper. It was important that we did this because a lot of people complain that Enlighten doesn't work kind of out of the box and you have to create your assets with it in mind. And there's mild truth to that. And so we just want to make sure that you can download something off the asset store, use it in this light mapper. It's fast, good results, and good to work with. So anyway, on the left is my scene, and on the right is my light map. And did I not put the arrows on this one? Oh, they're there. Good. So in this case, I have this stairwell right here is mapped there in the light map, which means that all the extra shadows and lighting for that stairwell is contained right there in that little square of the light map. So how do light mappers work in general, I guess? So the first thing we do is we unwrap our model, and you can think of it as if you take something and that's 3D and you flatten it out onto a table so that all the parts that were facing the outside are now facing up, and that's an unwrapped texture in UV coordinates. We do G-buffer rasterization, and then we do our baking and filtering, and then we apply that light map at runtime. So you go from this static information we just know color about, but we have shaded information about. So I kind of hand waved over this baking of a light map, this kind of middle, the middle arrow. So I'm going to talk a little bit about that. So once we have our flattened UV space texture, and we want to generate a light map. So what do? So for each pixel in our texture, we go to that spot in in the world, and we shoot rays out from the center of that pixel in all directions, and we bounce it off things until we hit a light. So, and what that does is every light we find, we know how far we traveled to get to it, and we know its color, and we also know what it bounced off of. So then we can figure out how much light does that light contribute to my texel, as we call them. So here's a little graph of that. We don't actually send just random rays out in every direction because statistically, most of our work would be wasted. And lucky for us, since you guys tell us where the lights are, what we do is we basically bias where we send the lights to where we know that they'll hit the light better. So most of our rays return useful information, and that way we don't waste a lot of time just like shooting like 70% of our rays over here when I know that the light is actually right there. I'll send most of my rays kind of in this direction and this direction, and less over here. Because these are the ones that are, like in this room's case, like the thing off the screen and the bulb itself are what are actually going to affect me the most. So why is it called the progressive light mapper? Well, the progressive light mapper starts off and it shoots, dozens of rays at a time. And it's going to shoot until, and we'll go through the settings, and I'm going to do a live demo of this. But it starts off and it shows you the results right away. So you can see here, like, this looks like a mess. Like, it looks terrible. You can see squares and blotchiness in it. But that's because it's only sent out a few rays. Did that update? Yeah. So you can see here, it got slightly better. Things are starting to smooth out a little bit. That's because we sent more rays. So we have more accurate information about what light is actually reaching each one of our texels. And then over time, with enough rays, it's just going to look perfect. There's some artifacting, I think, from the HDMI projection on here. But basically, the more rays you send, the better the results. And we show you the results as we calculate them and update continuously. So that way, what happens is you get initial feedback immediately. So before I jump over into a live demo, I just want to say that we were working heavily with Imagination Tech. We're using their PVR technology, their ray casting technology, to cast our rays and build our light mapping solution. And special thanks to Jens Fersen from Image Tech for helping me with some of my slides, and also Casper Storm Inglesoft, who is one of our main developers for it. All right. Boop. So here we go. So here I have a scene. And this is a multi-story dungeon. Kill things in the background. Don't save any of my work on the light image effects. That was terrible. So currently, and this will change by the time you get your hands on it, the lighting scene, it shares a lot of some of the UI space with the existing. So to turn this on, once you get your hands on it, all we need to do is your bake backend, and you change from a radiosity GI-based system like Enlighten, and we have the path tracer, which will be initially released as an experimental build. That's what I'm on now. So let's see what we can play around with. So if I switch over to my light map indices here, we can see where my light maps is. So my first thing is my baked resolution. So these are how much. Oh, damn it. All right, sorry. You guys should have said that way earlier. Wait, no, that's not what I want. I want. Oh, wait, yeah, okay. Sweet. All right. So basically what I did, recap, in the bake GI here, in our bake backend, I just switched from radiosity to path tracer. And then to see I just went to my scene view, and under bake GI, I looked at my light map indices. And this shows me exactly, each color here represents a different light map. So if I see a couple different colors, that means if I come over here, I'm currently baking 6 light maps here. I can change the resolution. I can make it, more accurate, less accurate. I can do specific things like, let's say this pedestal is super important, and the character's gonna walk up and like grab the egg of whatever off it, I can come in here and say, oh, you know what? This takes up 4 times as much space in the light map as it regularly would. And that way it has more detailed information. Am I out of time? I started 5 minutes late. All right, I'll wrap up. All right, let me just set this back to 1 then. All I really have left is set this back to something 4. I just want to kind of show you what happens when I move things. Oh, it crashes. Yeah, all right. All right. Experimental build, pre-alpha. Oh, man. It wouldn't be so bad if it took less time to crash. All right, let me just jump in real quick again. Arturo can suck it. Oh, wait, you're still here, sorry. All right. So, no! Life sucks sometimes. You know? I'm just going to jump to a random corridor. That's not going to work. We're going to do that. There we go. All right, main camera. Sorry, Arturo. All right, here we go. So I have some baked light maps. You can see them pop in. Open up my lighting window. So the key here is that we wanted a fast workflow. So if I grab things like this light, and I just decide to move it, I'll move it way off there. You can see the extends. You can see that right away, the light maps get thrown away. And then if we wait a couple seconds, I'll start getting my data popped in. And I just want to point out a couple things. Maybe. Aside from biasing and making sure we use the rays smartly, we also, you can see like here in the game view, like what I'm looking at in the scene view gets prioritized over what happens in the rest of the level. So you can see in the game view, because I zoomed in a little bit at my scene view, as I'm moving things around, I'll see lighting information more immediately there than I will be when I do in the rest of the scene. So basically, wherever you're working and trying to adjust your lights, that's where we're going to show you the information first. And then if we waited here long enough, the rest of the level pops in eventually, because it's right now it's like baking some random thing, but it'll pop open. So I just want to conclude with a couple things. You'll start seeing this get a lot faster, because this is all CPU right now, and we're moving it to the GPU. And it's much, much faster. And it's much, much faster on a desktop machine as well. The other thing I want to mention about image effects, the next big thing there that's coming out is that we're going to, instead of having separate image effects, we're working on the Uber effect, which means you're going to add one component to your camera. And what that means is things that can share passes will. So not only will things get more efficient and better performance, but also they'll be in the correct order that they need to be applied in. So you don't have to worry about like accidentally having, anti-aliasing on last or something like that. It'll be locked into the order that you need to actually apply them. I thought you left the room. I was just going to keep going. So sorry that was a little short. Your $4,000 machine is no bueno. Oh, look at that. Lastly, things that we're working on in graphics, DX12. We started working on Vulkan, texture arrays, GPU instancing. If you're using OpenGL 2.0 legacy support, we're about to remove that. So yeah. If that bothers you, which it shouldn't because our data says it shouldn't, reach out to us right away. Other things we're working on is shipping the progressive light mapper, faster shader serialization, and improved shadows for large worlds, and like I said, unify the cinematic image effect. And I'll be right outside for questions. Muchas gracias.